Hello friends, welcome back to my YouTube channel Tech Server Global. Hope you guys doing well. Today we are going to discuss on storage in Kubernetes. In last video, we had discussed about storage in Docker, how we can bind a storage in Docker. Today we are going to discuss storage in Kubernetes. Storage in Kubernetes is a core concept because containers are ephemeral. Likewise, data is lost when pod restart. So whenever we create the pod, simple using Nginx or Redis or any image, and we run it, and by login, enter into pod, we save or we create some file. Somehow that pod is restarted or created with new name, or somehow it been not working properly or crashed. So that file or the data which we had put, it's going to remove because it's not persist. So to solve that issue, Kubernetes solve this by providing persistent storage abstractions. And in this topic, we are going to clear with practical explanation, and it is very useful for learning interview and real cluster issues. So let's start with storage. First of all, we discuss why Kubernetes needs storage. So there are three points. One is pod can be recreated at any time. It is not like a service that if somehow service got stopped, we can manually start it. If pod is not working properly, it's going to restart. As we had few topics in the past, like to create the services, to create the deployment. So whenever pod going to crash, it will going to recreate at any time. Container loss data on restart. So application like database log upload need a persistent data. It is not something like you prepare some database and data is not some persist. So it is not a valid, or we can say the proper setup of any database or log or any kind of file based upload application or many more. So data should be persist. The second term is main storage component in Kubernetes. So how this component, and what are the different components that require to maintain storage in Kubernetes. So first thing is volume. So likewise, we had a discussion on Docker volume. Similar here, also we have volume in Kubernetes. A volume is mounted on a pod and lives as long as pod live. So simple thing, like say, if I create one Nginx based pod, and if I put some file, somehow pod got restarted. So or stop and start. So that particular content or data will be lost. So it is similar to the uh, likewise we have storage in image, like whenever we put some file, we restarted that pod, again we start, then data will be lost. So the example of that particular volume is like name and emptyDir. EmptyDir data is deleted when pod dies. When I say pod dies, that means if somehow pod is going restarted, or somehow it's not working or a crash, it will automatically remove the data and relaunch again. So let's start with this emptyDir, how it works and what are the use cases of this emptyDir. Okay, so I'm opening my VS Code. So this is something a YAML file for empty directory. So API version v1 kind pod metadata, and the name of this particular pod is nginx emptyDir pod. Under metadata, I define as a, under spec. Sorry, under spec, I first define a volume, and it is a volumes. What is the name of the volume? Let's say cache volume. So you guys might be surprised that why, if the data is being not persist, its data is being going to loss during the, whenever the server got, I mean sorry, pod got die. So what are the use cases? So somehow we can use in a cache, we can use to store local data, sorry, temporary data, not local, sorry, temp data. Okay, so that kind of use cases we can apply with this particular empty directory concept. So name of the volume is cache volume, and the oh, emptyDir defined as a then containers, the name, image, port number is container port, and within container I'm going to mount this cache volume. This name and this name should be same because I'm going to use this volume in this particular pod, and the pod have predefined directory because we are using nginx image, and nginx is having this default directory path where the index or other pages being there. Okay, so first we are going to run this. So Kubernetes is already up and running, so let me get pod. There is no pod in default, so let me run. I just create k as an alias for kubectl. Apply -f emptyDir. Okay, get po, sorry, po. So it's been creating. Okay, now it's running. Okay, now let me try to log in within the container. kubectl exec nginx empty sorry, let me copy paste it. -bash. Okay, so I am within the container. Now let me navigate to share nginx html. There is no such content. Okay, so let me put cat hello index.html. Sorry, echo, my bad, sorry. Okay, and now let me call. Okay, so here you can see, I can see I just pass hello keyword to index.html, and this particular storage is actually stored in this emptyDir. Now let me exit. Okay, get po. Okay, so container is up and running. So let me delete this. Okay, now let me try to rerun. Okay, get PO. Okay, now it's running. Now try to log in within the container again, sorry, pod, and simply I'm just call localhost. So it's basically a default page, not the hello, which I provided early on the prior pod. Okay, so this is something called emptyDir. Okay, so in emptyDir, data is deleted when pod is dies. Okay, so like we remove the pod and recreate again using same file, it is not working. I mean, there is no content in the location. So what are the use cases? As I mentioned, it is not persist whenever the storage, pod being die, automatically storage will be removed. So we can use in cache storage, sharing data between container, temporary processing the space, build and CI jobs, and fetch in memory. So these are the use cases for empty directory use cases. So if in your case, if you want to perform such kind of use cases, then you can use emptyDir concept. Okay, when not to use emptyDir. So these are the use cases when we can use. Now when we cannot use emptyDir, like if the database are user uploads log for multi-persist or any critical data, so this kind of not the ideal scenario for such kind of scenario. Okay, now it comes to PV and PVC. PV stands for persistent volume and PVC stands for persistence volume claim. So basically this is the idea of PV and PVC. So let me try to brief about PV and PVC. So first, as a storage admin, provide us some storage. Likewise, in this example, we have 100 GB. Okay, read write one. The forget about this policy. Later on, we'll discuss on this. So let's say storage admin provide us 100 GB, and we create a volume, and we want to use that volume within this given pod. There is one nginx, one is redis, one is node.js. Okay, so first, to use PV, we have to use persistent volume claim. So we have, as a user, as a Kubernetes admin, user have to claim that storage from PV, that I need 10 GB for node, 20 for redis, and 30 for nginx. So this particular PV can provide the storage up to 100 GB. Okay, so whenever we need to use or we need to allocate storage within the pod, first we need to claim that storage, which known as PVC, and that's volume which is assigned to Kubernetes to manage the storage is known as persistent volume. Hope this I try my best to explain this. So let's first discuss about persistent volume. Persistent volume. So first we discuss about persistent volume. Persistent volume is an actual storage in a cluster. It is a pool of resource storage which is your application use. Like as I mentioned, storage admin provides 100 GB volume. So as a Kubernetes admin, I have to I have to create a volume which is persistent and which we can use in within Kubernetes, right? So provision by admin or dynamically. I mean, we can manual a provision or dynamically we can provision. Back by means where we create such storage, sorry, such volume. So within EBS, EFS for AWS, Azure File and Disk for Azure, NFS, Chef, and local disk. Okay, so these are the technologies, or we can say storage based or volume based technologies, where we can claim, not say claim, but we can create persistent volume and we can claim that particular storage within the pod. So first we are going to create persistent volume, and what is the YAML file to create PV, and how we can get that PV. Let's take an example. Okay, so this is basically a YAML file for to create the PV. So the first one is API version v1. Kind is persistent volume. P and V is in capital. So because persistent volume. Metadata, name of the PV. I said first PV volume. Label, I said type. Now type should be defined. So here I define as a local, and here we see the local is a part of the storage. Spec, capacity, storage is 10 GB. Okay, so if you see this image, in this image here I have 100 GB, but in this particular example I'm going to use 10 GB. Okay, then access mode. What is access mode? So this is read write once. I will explain this access mode uh, in just few minutes. Let's say currently we have access mode called read write once. So one time, let me explain in brief first, so you guys have more idea about the storage class, where it is. Yes, this one. So there are three mode. One is read write one. In this example I put read write one. So what it means, one node volume can be mounted as read write by only one node at a time. I clearly mention node. So let's say if I have three node, so only one node can access this volume once. Okay, let's say what happened if I have three pod in one node. So all three pod can simultaneously access volume, but pod 1 from node 1 and pod 2 from node 2 cannot access simultaneously storage. So volume can be mounted as read write by only one node at a time. Read only many. So we can put as a read only mode, and for many, I mean for any node, for many node, and for any pod within multiple nodes. And read write many node read write volume mounted as read write by many nodes simultaneously. Okay, if I have to take an example, this is something I can put as a my database or a Mongo or kind of experience. This is something we can say read only, like anything that yeah, like I can take an example of machine learning template, or I can say any kind of read only data. some storage level or kind of that you are going to provide only read only access. So in such option you can use this. And last one is something for I can say the log metrics, if I say to multiple uploads. So this kind of options, examples we can fit over here. Okay. So this is something called access mode. Access mode define how many node can mount a volume and with what permission. Okay. So first I'm going to run this command clear kubectl. Sorry, I'm still in. Okay, I was still in the pod. Kubectl get PV. So I can see first PV is already there. Let me do delete hyphen app. Let's say PV dot YAML. Okay, because persistent volume already there. When I was testing this YAML files, I just tried to create it and it was there. So let me remove it. Meantime, I'm just changing to, let's say, 20 GB. Let's say, yeah, 20 GB is enough. Okay, one more thing. Here, I just put type called label. And this is something, a setup of kind cluster where we have multiple nodes. So let's say if I create PV, persistent volume, right? So after storing that particular PV, when pod is going to create, when this particular pod is going to create, how storage is work, because it's local one and it we are using with the kind cluster. So think on this part. Will later on I will explain this scenario. Meantime, hope this particular PV came out. Okay, so I just remove both PV and PVC which I had created. So first, let me try to create PV. I just change to 20 GB and type is local. So because I'm going to create in local. Okay, so create hyphen app pv.yaml. Okay, so now get PV. So here you can see PV is created with first PV volume name, size is read write 1, access mode, reclaim policy retain, status is available, and this one. So this is something I created with the PV. So physical volume, sorry, persistent volume is created. Now we have PVC, persistent volume claim. So as far as this diagram concerned, we have this PV. Now we want to use this storage within the pod. For that we have to create PVC. I mean we have to claim that storage, right? So to that we created PVC. So PVC is request for storage by a pod, like pod, PVC, PV and actual storage. So we have actual storage within the local storage. We have create that storage as a PV. Now we claim that storage. Okay. So that to claim that storage, we have this YAML file. Okay. So we have this PVC. Okay. API, read write one kind, persistent volume metadata, read write once, okay, and because it's similar to PV, and storage is 1 GB. I said I changed to, let's say, 5 GB. Okay, I'm going to remove this storage class. It's currently not in use, or keep it as it is. Later we'll discuss about storage class. PVC. So there is no such PVC. Now let me try to apply k apply -f PVC dot YAML. Okay, get PVC. So now here we can see its status bound. First value is capacity is 20, and it's required as a unset. Okay, now let me use this PVC in within pod. Okay, so now we have PV, we have PVC. Now to use this, we have this YAML file to create the pod. So it is similar to the YAML file for the normal pod, API version v1, kind pod, metadata, network storage pod, the name of the uh, spec, volume, name of the first PV. So PV we have created with the first PV volume. If you can see this first PV volume, claim name, persistent volume claim name is PV name is first PV claim. So if somehow if you change the name, or somehow if you created PV or PVC with different name, then you have to change it. Container name, Nginx image would be latest, port, container port, volume mount. Within container, I'm going to mount this first PV volume. Mount path is USR, share, and Nginx. Okay. Here we have node name called kind worker. So what it trying to do as a storage, what we did, we they use /tmp/storage. Now this is the little bit confusion, or I can say the little bit surprise element, because we are using local storage in PV, and here we have get node. There are 3 nodes. It is a setup with kind cluster. So there only one machine is there, and one machine create 2 additional node, and one is control plane node, and 2 is worker node, right? So there are total 3 node, and by default we know that whenever we create the pod, it will not going to store in local I mean the control plane node, right? So either it will going to create within kind worker or kind worker 2. So there are 2 worker, one is this and one is this. Okay. Here within this particular pod, what I mentioned that I need a storage of what defined in PV, but where actually going it going to store, as you guys said, local where, local in term of kind control plane worker or worker 2, because when we create a pod, it create within the node, right? So why I define this kind worker, because it going to, because I don't know whether if I create this particular YAML file, sorry, uh, pod using this particular YAML file, and this particular node not having this folder, then it continuously trying to creating pod, and until and unless it will not find that particular storage, it will not comes in a running state, because no such path is being found and it's trying to get that particular path. So what I'm going to do, I'm going to enter into this particular Docker container, because I set up with the kind cluster. So that Docker ps docker exec hyphen it kind worker slash bins bin slash bash. Okay, and I'm going to validate slash tmp. There is no such folder, so I'm going to create one folder called storage, emptyDir storage, and within storage I'm going to 1 2 3 4 5. Okay, so I created some files. Okay, now exit, and okay, now I'm going to run this file. Okay, this pod is actually going to create only on node kind worker. So whenever you use local storage, it is not ideal for multi-container, multi-node setup, right? Because somehow it is not possible to keep local disk in multiple node, right? kubectl apply -f nginx pod storage YAML. Okay, let me get pod. Container is creating. Here I can see storage in uh, running state, right? Now let me exec hyphen it nginx storage hyphen pod hyphen bash. Okay, and I'm going to pub slash usr share nginx and html, which I have mounted with the storage, right? And enter. Here you can see there are 5 files which I created in this particular node. Okay, and I attach same storage within the pod. If somehow, if I exit, if I sorry, kubectl delete pod and copy paste. Okay, and I'm going to rerun. Okay, I deleted, I rerun. Sorry, it's still being, now it's running. Okay, now slash cd usr share nginx and html. So here you can see pv uh, pvc is persistent, I mean storage is persist. So if somehow the port is not working properly, if it is crash or dies, data is still there. So this is the beauty of storage. Okay, now last topic is all about storage class dynamic provisioning. It automates the PV creation. Instead of manually creating the PV, Kubernetes use storage class. Okay, so let's say if I just clear and I said, sorry, I'm exit. I said kubectl get storage class So there is one storage class is already there because I just prepared as a kind cluster. You can manage storage class with NFS, uh, or we can say I think storage class with EBS, if EFS, with shared storage, NFS, and many more. Also, with storage class, you can dynamically map your storage within container. Okay, so if we need to create additional storage class, simply we can create again for with this local storage. Either we can use for Azure files, either we can use EBS. Okay, so simple. If I need to create storage class, I can create using this way: API version, storage create IOV1, kind storage class, local, and provisioner is rancher.io, which is the default one. Reclaim, delete, and wait for first consumer. Okay, so let me apply kubectl, apply -f storage class. Okay, get storage class. So there are two storage class. One is standard, one is local. Okay. Mm, now here I can create persistent volume with storage class. So what will the change if I have to use storage class? So API version is v1, kind is persistent volume claim, metadata name, access mode read write one, storage class name is local sc, and storage is 1 GB. Okay, if I say to use this PV, sorry, this is something going to access the path. It will going to run as a local path. Okay, so I'm going to create new additional PVC. K get PVC. Sorry, K get PVC. Currently, first PV is there. Now I'm going to create an additional PVC with a name called Nginx PVC. Okay, apply -f PVC additional class.yaml. Okay, now okay, bound. It will take some time, then it will bound with the change with the bound status. So in this way, you can use that particular storage class in local storage class in PVC. In future video, I might take an example of Azure or AWS storage class for additional. You will get more idea on that. So how do storage works? So first one is pod, then it went to PVC, then it went to PV, and either it can be cloud, it can be NFS, or it can be disk. Volume type and use cases. One is because it's ephemeral, empty directory, temp file, config map, app config, secrets, credentials to store the credentials, and downward APIs, prod metadata, and the persistence. We can use host path. Likewise, we had this in example. NFS. Okay, one thing, local node is not for prod. It is only for to have the getting the idea about the storage. NFS, shared storage, EBS, Azure disk, block storage, EFS and Azure files for share file storage, and FS for distributed storage. So this kind of persistent volume you can use and use it with this your better understanding. And for production, majority we use NFS or any kind of cloud-based storage. Access mode we already discussed. There are three: read write one, read write many, and read write many. Examples have this. Okay, stateful application for database. Yes, stateful database. Why? Because pod name, stable pod name, and stable storage per pod. Because we require database with consistent data. It's not like for one table it's having this much of data and this much having different data. We cannot afford that. So for that reason, we have to use storage. Kubernetes storage in real life with AWS, we use EBS database for RWA and EFS for RWX. And on premise, we use NFS or Chef or Rook or Long. Hope I tried my best to conclude the storage in Kubernetes. Uh, if you like my video, please like and comment if you find any wrong with my teaching methodology, and you can please like and subscribe the channel. Thank you so much for watching this video. Have a great day.